Okay, so first of all, let me preface what I'm going to say with a disclaimer, which is that this talk is going to be almost entirely PowerPointless, and I'm going to be doing stuff live with very immature technology, and knowing Murphy's Law, some of it will work and some of it will not. Hopefully some of it will work at least, but you know, things tend to go wrong when you do stuff live, but I'm willing to take that chance because I think it's worth doing that to, you know, kind of help people here get their head around what, you know, is really a little bit of a complex landscape, but once you kind of understand the lay of the land, I think it's fairly easy to work within it. So I'm going to start with just maybe 5 PowerPoint slides to bring people up to speed on what accessors really are, okay? So from my perspective, they're a combination of 2 widely used design patterns. One that we call asynchronous atomic callbacks. Some people also call it the reactor pattern, but I find that term not very specific, so I prefer the more specific term, asynchronous atomic callbacks. And this is a design pattern that's very widely used in web applications where short atomic actions are interleaved with atomic invocations of response handlers. So if you have some client program, by the way, if I move my mouse on the screen like this, do people out there in the land see a pointer?
Yeah, we see it move.
Okay, that's good, because that's the closest I have to a pointer. Okay, so you've got some client program, and you've got something you want to interact with, and you issue a request, and the request, you know, it's common for these requests to use RESTful interface, which REST stands for Representational State Transfer. So the entire state information that's associated with the request is carried along with the request, okay? But the key thing about asynchronous atomic callbacks is that the response to the request doesn't come back immediately, and the client program doesn't block waiting for the response. So sometime later, a response will be invoked by invoking a callback function in the client, and that callback function will be invoked asynchronously with anything else going on in the client, but very importantly, it'll be invoked atomically with respect to everything else going on in the client. So the client really consists of a whole bunch of invocations of these atomic callback functions, and when a callback function is invoked, it runs to completion before any other callback function can be invoked. So that atomicity is really important, but the order in which these atomic callback functions get invoked is arbitrary and will depend on the response times of the thing. Okay, so this is a very widely used pattern, and in the web it's used primarily to hide the latency of network accesses. So if you're accessing a network resource, you don't want to just block your program waiting for a response, because often the response can take, you know, tens, hundreds of milliseconds, maybe longer, and so blocking your client program for that extended period of time is really, you know, leads to very poor quality of service. So this is used in pretty much all JavaScript programs that run in your browser. When you go to a web page, it's used in Node.js for server-side functions. It's used in frameworks like Vertex, and it's also used in cyber-physical system frameworks, most notably TinyOS, which is a system that's designed for extremely lightweight battery-powered microcontrollers. So, okay, so that's a common design pattern. Now, there's another common design pattern that's also gained a lot of attention recently and a lot of use in you know, enterprise-scale computing, which is an actor pattern. And the idea of an actor pattern is that you have a bunch of conceptually concurrent functions, like this weather function, for example, shown in the middle of the screen, and these receive streaming inputs. So you make your request by streaming messages to this weather object, and the weather object will respond with a stream of responses, okay? And then you you concurrently compose actors, so you can have an actor that's creating a sequence of requests that is running concurrently with the actor that's handling those requests, which is running concurrently with an actor that's handling the responses. Now here the actors are genuinely running concurrently, so these are not atomic invocations. And the reason that this is safe is that these actors do not share data except through the messages that are explicitly passed from one to the other, okay? So you can see these are two very different ways of handling concurrency and asynchrony. One has genuinely concurrent, possibly even parallel execution of actors with isolated data sets and then a messaging schema between them, and the other has a single shared data set and asynchronous invocations of atomic callback functions, okay? These two patterns are both widely used in enterprise computing and in web computing, and the essence of actors is to combine the two, okay? So if this weather actor receives a request, it will issue a request to a thing, okay, which might be a weather station, it might be a web-based service, it's something like that. Sometime later, this weather station will respond asynchronously. That asynchronous response will invoke an atomic callback within this weather object. So now the callbacks are atomic within an actor only. Across actors, they are no longer atomic. They may be, in fact, executing concurrently, but they don't share data, so it's actually safe to execute them concurrently in separate actors. So now you can kind of get the best of both worlds. You can get the parallelism of actors and its asynchrony together with the asynchronous atomic callbacks. And our observation is that when you try to use actors by themselves for complex applications, or you try to use asynchronous atomic callbacks by themselves for complex applications, it can get quite difficult to do. So there's, you know, a lot of nice user studies about asynchronous atomic callbacks that shows that as applications grow, you get this, you know, sort of endless chain of callbacks that can be very difficult to reason through. And our feeling is that this pattern, by combining this with actors, we can mitigate that because the asynchronous atomic callbacks get used for a more isolated piece of functionality and then get composed with other pieces of functionality through the actor pattern, okay? So in my view, this is really the essence of accessors. It's a design pattern for the Internet of Things that embraces concurrency, asynchrony, and atomicity, okay? We're not alone in pursuing this approach. In fact, there are two rather nice projects out there, one that comes from IBM called Node-RED. This is a screen image, so Node-RED has a visual editor that runs in a browser, so it's an HTML5 based visual editor where you stream together in an actor pattern pieces of functionality. And then a second rather nice project, which is actually one of the key people in that is an alum from my group, is a project called Calvin from Ericsson. And that one does not currently have any visual editor, but it has essentially the same combination of patterns, actors and asynchronous atomic callbacks. I think that our work within the TerraSwarm effort is distinct from these two, particularly in our emphasis on the rigorous contracts of the interactions. So I think we're, you know, a big part of this research is to do this in a systematic way that uses well-defined models of computation for the interaction. And we have a lot of experience with these models of computation over the years, and so we're able to leverage that for this. Okay, so last PowerPoint slide that I'm going to show before I go PowerPointless is an outline of the architecture of our version 1.0 implementation. Now, the most important piece of information probably in this whole talk is this URL, http://accessors.org. Okay, so we're using that URL to basically expose to the world a work in progress, which is this development of this accessors infrastructure. And it's very much a work in progress. And you can have a look at what's there, and a lot of it is under wiki infrastructure, which you can edit. So fix errors, elaborate on things where they need elaboration. Feel free to improve things. We're hoping that there will be a community working on improving things. Okay, so the landscape is a little bit complex here for very good reasons. So an accessor, represented by this box, is meant to be something very portable. The idea of an accessor is that it can run on a variety of different hosts. Eventually, we hope ranging from extremely lightweight microcontrollers up through, servers in a server farm, okay? But it's platform-independent code. But of course, you can't do much with platform-independent code, particularly in an IoT context. You need to be able to access platform-specific services like sensors and actuators. So the way this architecture works is that an accessor runs under the control of a host, an accessor host, or a swarmlet host. We use those terms interchangeably. And the swarmlet host provides the context in which the accessor runs, and it can provide platform-specific services to that accessor. So the way that it provides platform-specific services is through modules, and these modules are standard JavaScript modules. So they're, for anyone who's a web programmer, this use of modules would be really quite familiar, okay? You can instantiate modules in a JavaScript program and then invoke functions on those modules. And what we've been doing is defining a standardized API for a set of modules and then providing implementations of those modules on a variety of hosts. Okay, so that's the overall picture, and the picture gets a little confusing sometimes because it can be confusing whether you're working with the platform-independent code in the accessor, whether you're working with the platform-specific code in the module, or whether you're working with the platform-independent API of the module, or whether you're working within the host, okay? So there's a bunch of moving parts here, and you sort of have to get used to the moving parts and know which one you're talking about. So I'm going to switch away from PowerPoint and try to make this really concrete by going through a bunch of examples here. Okay. So as I said, the most important thing is accessors.org. Okay, so that's a web page, looks like this. It has some, brief introductory material on that web page. If you want to work with the current implementation of the hosts and our prototypes of accessors, then you will want to get access to this SVN repository, okay, which there's instructions on this page for doing that. And everything that I'm going to run during this talk is currently in either that repository or a second repository, which is in the Ptolemy 2 host repository, okay? So I can't read that. You have
that you are not sharing your screen. The button that Christopher was saying is not showing.
What's not showing?
The sharing button in the WebEx that is in the top. It seems that this screen is not, if you are not sharing, it seems that you are not sharing.
That's a problem.
Yes, that one is not sharing.
No, we're seeing, like we could see your web browser and things like that. What's the issue?
Oh, okay. So I was just checking that what he's sharing is a web page. That's all.
Yes. He's sharing everything, including his unnumbered Swiss bank account, which we're now moving to a different bank account.
Oh, okay. All right, great.
Right. Okay. All right. So here I'm going to go through a little bit of what's on this web page as a matter of orientation, because I think that if you want to work with accessors, this is going to be your entry point, and getting, a feel for how to navigate through this, I think, is going to be useful, okay? So probably the most important link here is this wiki link, okay, which takes you to the wiki that is currently defining our accessor project, okay? And I want to walk you through a little bit of what's on this wiki page. One is that if you're going to write accessors, this very first link on this home page for the wiki is an index of the functions that you will invoke with links to explanations of these functions, okay? I want to emphasize what's on this page is the entire Accessors 1.0 specification. That's all there is, okay? So you can see it's only little more than one page, right, of, you know, maybe 3 dozen functions, and that is the spec as it stands currently. I'm sure that it will evolve over time and get more elaborate, but right now it's really quite small, and I'd like to keep it small, okay? Now, that's just a summary. A more useful page for getting into it is this second link, which is the actual specification, okay? And that specification begins with a minimal accessor example, okay? And what I'd like to do is just show you this minimal accessor example in action, okay? So I've selected the text, and in order to avoid having to type a lot of stuff really quickly, I'm just going to copy it into my clipboard, okay? And then I'm going to switch to one of the hosts, one of the 3 accessor hosts that we have, which is the one that we call CapeCode, okay? And I'll show you a little bit more about CapeCode later, but I'm just going to use this to show you how you can experiment with accessors quite easily using CapeCode. So CapeCode is started on the command line using a command line function. It's like this, Virgil minus CapeCode, okay? Once you've installed Ptolemy 2, you can instantiate CapeCode this way, all right? So that's what I've done here. I've got the welcome window, which has links to a bunch of demos, okay? Has links to some documentation, a list of authors, things like that, okay? So first, let me just create a blank swarmlet, okay? So I'm going to create a blank CapeCode model, and what I'm going to do is take from this web page this minimal accessor example, and I'm simply going to prototype that in CapeCode, okay, and then use it. So in CapeCode, the easiest way to prototype an accessor is to drag in a blank JavaScript actor from the library. If you don't know where to search for this, you can just search for it, JavaScript, okay, and it'll take you right to it. And then if I open this actor, I get a text editor for entering my JavaScript program. And the text editor is initially populated with some comments that say, put your JavaScript program here, add ports and parameters, et cetera, et cetera. Interestingly enough, most people leave this comment here, and so often you see accessors where the first line of the documentation says, put your JavaScript program here. I recommend deleting this and replacing it with your accessor specification, okay? It should have documentation, but this, you know, here we don't have any documentation. So let me just walk you through what is in this code. So there's 2 key parts. There's an interface definition, which is at the top, which is by convention in the accessor specification defined in a function called exports.setup. So exports.setup is defined to be a JavaScript function that defines an input named input, defines an output named output, okay? And that's it. That's an interface specification. So if I save this, in fact, you might notice that that there are ports that have now appeared on this accessor, which implements that interface. The port named input and the port named output are now the ones specified by this interface. So all I did was a Control-S, which is save command, apply, I guess, is actually the name of the command, okay? So, all right. Now, the second piece of function of this accessor specification is functionality, okay? And there's a number of ways to specify functionality. One is, the simplest way is to specify a function called fire, which will be invoked basically anytime the host chooses to invoke it. Typically, if you provide the actor with new input, the host will invoke the fire function, okay? So in this case, the fire function sends to an output named output the result of reading the input and multiplying it by 2. That's it, okay? So very trivial piece of functionality. Let's use that functionality. So to use that functionality, I have to put it into some test harness. So let me just provide it with a single data value, say with value 42, which I will provide at time 0. And then I will want to display the result. Okay, so now I've connected 3 actors, one of which is my new accessor prototype. And when I run this, I get, sure enough, as a result, a displayed value of 84, which is 42 times 2. Okay? All right. So rather trivial piece of functionality, but nevertheless, that's really all you need to be able to get started. So now you can go through back to this tutorial, and you can go through in the spec and see some more elaborate ways of doing things. So for example, instead of specifying a fire method, a fire function, which will respond to any input, I could add an input handler to respond to a particular input on the accessor. And this illustrates the common JavaScript pattern, okay, of asynchronous atomic callbacks. All right, so let me copy this and paste it into my accessor prototype. Whoops. And then first, let me verify that it, in fact, does the right thing. Whoops, I need to stop this and restart it because there's no more single event. Whoops. It did not do anything.
Edward, Alberto pointed out that you forgot a line, but I don't know if you did.
Yeah, you put it in the export file instead
of right.
For initial line.
There you go. Sure.
Yep. This is one of the things that comes with, you know, going PowerPointless, right? And one of the things I've discovered is that when you do stuff in front of a bunch of people, your brain becomes unable to see these kinds of defects. So it's good to have people in the audience that are paying attention. Right, so what the reason is that I want this to occur here is I want to add the input handler when this thing gets initialized, and then I want that input handler to be invoked each time this a new input arrives on this input, okay? So now, in fact, it does work, okay? Now, one thing I'd like to point out is if you're unfamiliar with JavaScript, okay, there's really only 2 things that you need to internalize that are both weird, okay? JavaScript is unlike any other language that I've worked with, and I'm fairly new to it, okay? So, you know, I had to kind of understand these things. One of them is simply this use of asynchronous atomic callbacks, right? The fact that I invoke a function and pass it a function that's going to be invoked sometime later. That's okay, I can handle that. What's weirder is understanding the context in which that function gets invoked, okay? And the strangest thing about this is the use of this keyword this in JavaScript, all right? So the fact is that when you add an input handler, you have very little control over what the variable this will be when this gets invoked, okay? So in this particular piece of JavaScript, what I'm doing is I'm capturing the variable this in a variable with an arbitrary name. This need not be self, it can be x, okay? It doesn't matter what the name is, right? But I capture the value of this, and then even more strangely, this looks like a local variable in this function, but it will actually persist beyond when this function returns, this initialize function, and will be used whenever this input handler gets invoked, okay? So the value of x will persist as long as there is a possibility of invoking this callback. This takes some getting used to if you're not used to JavaScript. To help you with this, on the wiki page, we have pointed to some tutorials that some of us in the group have found helpful to understanding how JavaScript works in this regard, because it's going to be very difficult to write code with this until you understand how JavaScript works in this particular quirky aspect, okay? But rest assured, you know, it's not that hard to learn, and there's millions of people around the planet who understand this, so you can probably find someone at the desk next to you who can explain it to you, anyone who's done any web programming, basically, has had to deal with this issue, okay? All right. By the way, I should, just as an aside, explain why we're using JavaScript for this, right? And the reason is really inspired by its use in the web, because in the web, your browser is able to instantiate untrusted JavaScript code, and it provides the context, the browser provides the context in which that code runs. So the browser actually has complete control over what that JavaScript can do. We're mimicking that pattern here, where the Swarmlet host has complete control over what the accessor can do. It can grant access to resources or not grant access to resources, and we need to be able to have that control, right? So this is a property of JavaScript environments that they always run within a context that completely controls access to all resources. The JavaScript language has no built-in access to resources. There's no I/O built into Java. You can't do any input or output in pure JavaScript. You need resources from your context, from your host, in order to be able to do I/O. So that's the reason for that. Okay, so just walking through a little bit more of what's on this page. So I mentioned the interface definition is what is specified in this, primarily in this exports.setup function. You can specify inputs, outputs, parameters. There's also an object-oriented hierarchy, so you can extend an accessor, or you can implement an accessor interface, so you don't have to, copy these interface definitions, and you can subclass accessors to create refinements of existing accessors. Documenting accessors is important. We have a very systematic way of doing the documentation. If I go back to CapeCode and I browse the accessor library here, so this accessor library that's shown in CapeCode is actually pulled live from our SVN repository. So if you check in a new accessor to that repository, it will automatically appear in this list of accessors. Now, these are organized by subdirectories. So, for example, one of the accessors, you notice actually when I open this, you might notice in the background that it's actually even doing an SVN update. So it's making sure it has the latest version of this library from the repository. So one of the accessors that we have written, actually this was written by folks in Michigan. Okay, whoops, it's trying to connect. Oh, right, my model is running. Stop running. Oh, dear. Stop. Thank you. I dragged in this accessor, and the model was actually running, so it invoked the initialize method, which tried to connect to a Scarab robot, right? The Scarab robot has documentation, which you can right-click on the on the accessor and get the documentation, okay, for this. And the key thing is that this documentation is included in the source code for the accessor, which I can view by just looking inside the accessor. Okay, so this is the documentation. You can see that this file is approximately half documentation, okay, and half functionality. So the documentation is important, it's integrated, and the instructions for how to write the documentation are included in this accessor specification. The way you specify functionality is explained here. You can also specify composition of accessors. I'll come back to this later. So an accessor can consist of a bunch of accessors that it instantiates and connects in an actor network, okay? An example of that is given right down here. Here is a definition of an accessor that instantiates an interconnection of accessors shown in this image below. So in particular, this line right here instantiates a gain accessor from a test library. So test/test_gain is a test accessor. It sets parameters of that accessor. It instantiates a second adder accessor, and then it connects those accessors. It defines an input, it defines an output, and it becomes an accessor. Now, it'll react to inputs provided here by invoking the reactions of these contained accessors, which will then provide outputs. So this gives you, so you have a bunch of mechanisms kind of for reusing other code. You can either reuse existing accessors by creating compositions this way to create new accessors. You can subclass accessors to specialize their behavior. You can implement an actor interface and then completely change the functionality, etc. So these are mechanisms for reuse that are built in. Okay. The way that accessors are executed is explained in this lower part of the specification. And then finally, there is recommended coding style for writing accessors so that we get a common look and feel, at least in our own repository. We would like to have a common look and feel. So for example, simple things like, use camel case for variable names, use complete words, not shortened words, things like that, which, programmers have their own preferences, but when you have a library of components, it's really much better if the library has some consistency. It makes it easier to read the library, easier to understand it, and so on. So we would really like people to use a common coding style, and there's some arbitrariness in the coding style. Some of you will have your own preferences. Please try to subjugate your preferences and use the common one just because there are benefits from having a common style. Okay. All right, so that's the accessor specification page, and that's just the second link on this main host page. The remaining link is, the next important one is the host-provided libraries, okay? So here's where the host has to provide access to capabilities, resources. If you want to get access to the camera, for example, you're going to need access to this. So let me go through a couple of the demos, okay? I'm going to throw away this model and just open up a demo or two. So if I start up CapeCode, there's a link to demos, and there's a bunch of demos that have been created, some of which are less mature than others. So this list tries to be honest about which ones are more mature and which ones are less mature. We want to expose to the public the less mature ones because this whole thing is a work in progress. And, hopefully you'll get inspired if you want to do something with audio, for example, to start with this less mature thing and make it better, right? So let me pick one of the more mature ones. So here is an image annotate demo. And this one includes three accessors, actually, from the accessor library. So again, the accessor library is here. One of the sub-libraries is this cameras library, and there's only two cameras in here. FOSCAM is a manufacturer of networked cameras, okay, that provides a particular, defines a particular API. It's a RESTful API, but it's a very particular API. And so this accessor translates that API into an actor model and, you know, provides a mechanism. Camera is a similar one. Here's an instance of it in this swarmlet, okay? But this one uses, gives me access to any cameras that are currently connected to my swarmlet host, okay? Either a built-in camera or a USB camera, okay, will be discovered by this accessor, and I'll have access to it, and I can use the camera. Okay. The motion detector here is really a service. Okay, it's a service accessor. It provides access to a piece of functionality that operates on sequences of images. And similarly, this image Annotate is also a service accessor. It's not providing access to hardware resources, sensors or actuators. It's providing access to a service. In particular, what image Annotate does is it takes an input image and superimposes on it a graphic that is specified using SVG, which is a standard way of specifying graphics. Okay. So here there's a graphic that is actually just a star shape, okay, specified in SVG. And if I zoom in on this, you can see that there's a rotation input, there's the image input that's going to be annotated, and there's a translation input that will control the position of this graphic, okay? And then there's an image display. Okay, so what does this do? When I run this, first of all, it will grab access to my local camera, which is also being used for this telecon, so hopefully we will, it seems to be sharing nicely, okay, so hopefully
yeah, we can see you with your star.
With my star in the middle, right. So actually, the way this swarmlet is working is it's doing motion detection, and the star is, first of all, rotating in proportion to the amount of motion. So you can see as I move more quickly, the rotation speeds up, okay? But it's also tracking the location. So if I, you know, provide motion in opposite parts of the image, it'll simply translate the graphic to the position in that motion. I mean, in that image, okay? So this is an example of a composition that you can do of capabilities, right? And this one has, in particular, a sensor composed with some services, composed with an image display, okay? Those services do not need to be local. So what I'd like to do next is show you, first of all, you know, so far it may look like this stuff is very CapeCode specific, right? You need to be in CapeCode to instantiate these things, but that's actually not quite true. It happens that CapeCode is, I think, at this point, the most mature implementation of a host, but that's simply because we've implemented more of the modules on CapeCode, and we're hoping that as a community, we will implement all of these modules on the other Swarmlet hosts to the extent that the host is compatible with the modules. So obviously, you can't implement a camera host, a camera accessor on a host that doesn't have cameras, right? Now, okay, so first I want to emphasize how that the presence of a camera is a host-specific thing. The accessor itself, if I look inside this accessor, this code is by design host independent, okay? The host dependence is expressed in this one line right here, okay? Where I have invoked a function called require, and this says simply, I require a module named cameras, okay? The host has to provide that module in order to be able to execute this accessor. If it doesn't provide that module, this accessor is incompatible with that host, okay? All of the host-specific code should go in that module, not in this accessor code. So nothing in this accessor code should depend on the particular host. It shouldn't access hardware, it shouldn't invoke Java, it shouldn't do anything except pure JavaScript. Hey, so that's how that dependence works. Okay, so now let me show you, let me go back to the wiki page, all right? So there's a bunch of built-in JavaScript modules which are supposed to be provided by every host, okay? So every host needs to provide these modules, but they're not, you know, they're not very, they're sort of generic pieces of functionality, so a way to log text messages, for example. The more interesting library is the one of optional JavaScript modules, okay? So the cameras module, which was used by this cameras accessor, is defined on this wiki page. Any implementation of a JavaScript module that conforms with this API is a valid implementation of that module, regardless of what it's written in. If it's written in C and provides a JavaScript interface, that's fine. If it's written in Java and provides a JavaScript interface, that's fine. If it's written in Node, provides a JavaScript interface, that's fine too. Anything that provides this JavaScript interface is an implementation of that cameras module, and if the host has such an implementation, it can use that cameras accessor. Okay? All right. So what are the other hosts? Let me go to the browser host. Okay, so here's a list of hosts that have been implemented. The common host is actually pure JavaScript. So it'll run on anything that runs JavaScript. But as a consequence of that, as I mentioned, pure JavaScript has no I/O, right? So it can't do any I/O. So it's kind of limited, right? But all three of these other hosts use that common host and just extend it with platform-specific behavior. So all the generic stuff gets put in the common host. The other three use that common host and elaborate on it. Okay, so let me go to the browser host. So the browser, the host, let's see. I need to actually go to the host. Okay, so here is a browser, Firefox, that is actually now running a Swarmlet host, okay? And one of the things on this Swarmlet host that it did was it actually instantiated a list of all of the available accessors in the accessor SVN repository. That's one of the utilities provided by the host, is that I can, merely by putting the right, actually an HTML div of a certain class in my HTML file, I get a library of accessors, okay? And I can now instantiate those accessors. So for example, if I go to the services library, one of the accessors is the StockTick accessor. And if I click on this, I have now instantiated this accessor within my browser host. Let me just show you the host independence of this. So if I am in CapeCode, I go to accessors, I go to services, it gets from the same SVN repo the StockTick accessor. And I can drag it into a model and connect it up graphically, okay? The StockTick accessor has an input named symbol, two outputs named response and price, and some parameters, timeout parameter, for example, okay? So that's the StockTick accessor within the CapeCode host. And this is the StockTick accessor, the same source code within the browser host. In fact, I can look at the code right here, okay, and verify that it's the same code that I see here, okay? Exactly the same JavaScript code in both cases. let me hide the code, all right? So now, in the browser, this has actually instantiated the accessor, and it ran the setup function, okay? And then once it had run the setup, it had defined the interface to the accessor, so it created in HTML tables for the parameters, the inputs, and the outputs of this accessor, okay? So one of the inputs is the stock tick symbol. So if I would like to find out how one of the TerraSwarm sponsors, IBM, is doing today, I can say react to inputs and see that the last trade price is 131.92 for IBM, and this is pulled off of a Yahoo server, okay? You can see the full ugly JSON response provided by the server, which was then further processed by this accessor to just extract the latest stock tick price and provide that as an output. Okay? So that is an instantiation of this accessor within the host. Now, if I try to instantiate the camera accessor, okay, I get an error message. And it tells me, in fact, why. The modules that are required are util and cameras is not supported by this host. We haven't gotten around to implementing any mechanism for the browser host to get access to the camera. I hope someone who's watching this will get inspired to do that. The API for this module is defined. Anyone who's done web programming probably knows how to do this within a browser. My browser is, currently accessing my camera in order to do this telecon, so clearly browsers can do this. So there's, all you need is an implementation of the module, and then in principle, you should be able to instantiate and execute this accessor within the browser host. Now, let me show you a composite accessor. So if I go to the test library is actually a set of accessors that are providing regression tests. These are the infrastructure for regression tests for all three of the hosts that we've implemented so far. Okay. And
hang on, Edward. I'm watching it on two computers, and I'm getting lag. Like it didn't advance. Okay, now it advanced. It caught up. I don't know what's going on. Okay, please proceed. Thanks.
Okay. Yeah, so stop me if I need to pause to allow the network to catch up. But hopefully you can see the test library now, which contains about a dozen test accessors.
Yes, okay. We can.
And these accessors, by design, these accessors are designed to be able to run on every host. Okay, so they don't require any particular external modules except the built-in ones, right, that are required to be provided by every host. Okay. Browsing these accessors is potentially quite useful as a way to just learn how to write them, right? So here's an adder accessor. I can give it two numbers, 1 and 2, say react to inputs, and it says, yeah, the sum of those is 3. And I can look at the code to see how that was done, and there it is, right there, and that's the entirety of the code. Here's the documentation for that accessor. This documentation, you might notice, is also used in the browser host. It gets the documentation that's in the source code gets translated into HTML and rendered by the browser host. Okay. So let's see. Let me show a composite accessor. So this is a composite accessor that contains two accessors, a gain and an adder. This is the one that I showed a picture of earlier. So what it does is it multiplies the input by 4 and adds the results to the input. So if I provide an input 42 and say react to inputs, it multiplied 42 by 4 and added 42, and hopefully that yields 210, right? The contained accessors, whoops, here's a bug in the browser host. It should be listing the contained accessors here, and it seems to have bug in the code. But you can look at the source code and see this is the source code that I showed earlier. The accessor is defined entirely by what I've just highlighted. It has an input named input, an output named output. It instantiates a gain accessor, which is test gain. It instantiates test adder, which is the one that I showed before. It connects those, and it's done. You now have a composite accessor that you can execute within this host or any other host, for that matter, right? So again, I can emphasize, I can take this test library, and it's updating from the repo, so I can see on the command line, and test composite is this guy, and if I look inside, it's exactly the code I just showed. Okay, pulled from the same repo. All right, so let's go back to the accessor home. This is the main entry point again. Accessors.org redirects to terraswarm.org/accessors. So all you really need to remember is accessors.org. You can get directly to the browser host with this link, okay? You can also get information about the CapeCode host here, all right? And the NoToast, okay? So the NoToast is not particularly well developed yet. There's very few modules, but the infrastructure is there, and I'm hoping that, again, that the community will develop this further. But I'd like to show you, give you a sense of what it does. So this is, I think, a very complementary host to the two that I've shown. And let me just pull up a shell. And hopefully, do I need to increase the font size on this, or is this legible?
It's a little small, but bigger. I'm up in front, so bigger would be better. I mean, most people are watching from screens, but there's actually a lot of people here in 337. So.
Okay, let me. I think I just found. Where did it go? Bigger. Control plus. Let's try that.
Command plus. Yeah.
Command plus.
Command. That was, the cursor's bigger, so type something. Yeah, that's better.
Okay. Here, it's getting clipped on the bottom of my screen.
Oh, we need to resize it slightly then.
Okay.
Just grab the top and shrink it. Yeah, there we go.
All right, there we go.
Okay, that looks good from here. Please proceed.
Okay. So let me go to the place that I have my my copy of. Oh, wait a minute. Oof, no, I don't want to be. This is running on the Scarab. Sorry. I'm getting ahead of myself here. I don't want to run the. Okay, let's do it here. Okay, so the root directory for my copy of the SVN repository is right here. Okay, so if you clone the SVN repository, this is the directory that you'll see. And the interesting thing is the libraries. So, for example, the cameras. Okay, camera.js. is in the repo here, foscam.js is there. These are the documentation extracted from those files, and these are icons that are used by the CapeCode host. Okay. In addition, there's a subdirectory called hosts, which has a subdirectory called node, which defines the node host. Okay. Now, I personally have a really lousy memory. Okay. So I tend to put things into test subdirectories, and in particular, there's a README file here that explains how to run the node host and do some simple tests, okay? So if you want to get started, look for a test subdirectory, look for a README file, and walk through what it does. But let me just go ahead and run the host, and if my memory serves me without the help of the README file, I'll be able to do it. So the NoToast is defined in a JavaScript file right here. So I just run the NoToast, and it's an interactive host. It's a textual interactive host, okay? So now this is quite complementary from the browser. The browser can just instantiate predefined accessors. The CapeCode host allows you to graphically build up models. This one allows you to textually, interactively build up models, instantiate accessors, and interact with them. So for example, I can define an accessor by saying I want to instantiate and give it the name an instance of, say, test.adder, okay? And it tells me that it instantiated an accessor A with class test/adder. Now, one thing that's a little disconcerting when you use the NoToast is that it keeps saying undefined. And the reason for that is that the particular JavaScript statement here is a var statement. The var statement declares a variable, and it happens that in JavaScript, the var statement returns undefined. It doesn't return the value of the variable, which is a little odd to me, but if I want to examine the value of the variable, I can do it like that by just typing a carriage return, and I see actually I got a whole big JavaScript object, which is an instance of the accessor, okay? So A has a bunch of properties inside of it that are instances of the accessor, okay? So what can I do with this? Well, I can initialize it, okay? I've just invoked the initialize function on this. I can find out what its inputs are. It's got two inputs, input left, input right, and I can provide inputs. If I remember the syntax correctly, let's say on input left I provide 42, and on input right I'll provide 43, okay? And then I can ask the accessor to react. So it reacted, but all I got was undefined, okay? But I can ask, what are the outputs? There's a sum output. I can now get, I think, latest output from sum is 85, okay? And then I can do wrap up, oops, and I've now finished the execution of a very simple swarmlet. Okay, now this is meant to be illustrative that now you can, you can script all of this. The particular interactive host here, I don't know how useful it'll be, but the source code for the host could be quite useful, right? Because now you can write node programs that will build up swarmlets, instantiate accessors, interconnect them in arbitrary ways, process the data that's going to be provided to them in custom ways, etc. So you can wrap these accessors in custom JavaScript code very easily. And in fact, I would encourage you to look at the swarmlet host, the host file definition itself. It's not very big, actually. The JavaScript file is, I'll just scroll through the entire thing. That's it. That's the entire host, right? It's about 4 screenfuls of code. And you can use it, you can read through it to see, all right, this is how a JavaScript instantiates accessors and can do things in a scripted way. Okay. So let's see, how are we doing for time? Well, okay, so now what I'm going to do is try to do something a little more interesting, okay? In particular, I'd like to create a non-trivial accessor from scratch, right? So in particular, the accessor that I'm going to create is a chat server. Okay, so it's going to be a network service, and then I'm going to show that I can use it to build distributed applications. In fact, I'm going to show how to use it to talk to robot. Let me actually, before I go and run this thing, show one of the robot demos. So the Scarab demo here, which I hope will work, has an instance of the Scarab robot, and the Scarab robot is, let's see if I can get it on the screen.
So we can't actually see your screen. I think what happened was we can see it when you run the Ptolemy app, but otherwise we can see it when you, we have a little window in the upper, well, for the video,
okay.
And people move back to full screen. Like you can click on this, oh, there we go.
Yeah.
That's
okay.
good.
Well, let me just run the app, okay? So here, this application is running, and let me show you the robot. The robot is over on the floor there. This is one of the robots that was used in the Wait What demo. So these are from Vijay Kumar's group at Penn. It's got a little LiDAR on top and some wheels. And what this particular model is doing is taking the video signal that's coming in, let me show you the model, from the camera and doing motion detection on it, and then with a small little script constructing motion commands for the robot in response to the video, okay? So in particular, if it detects motion on one side of the screen, let's see if I can get the robot on the screen. If it detects motion on one side of the screen, the robot turns one way, okay? And if it detects motion on the other side of the screen, how to do that? It should turn the other way. So depending on which side of the screen it's got the motion, it turns one way or the other, all right? So it's a slightly silly application, okay? But the point is to show composition of services here, because I've taken, you know, the camera accessor to get my camera data, the service to detect motion detection. I've put in a little bit of glue logic, and just, you know, I don't want to hide anything behind the curtain here. So let me show you the glue logic here, because this is a common thing that you need to do when you're stitching together accessors. You know, one accessor will require inputs in the form of a particular data structure. Another accessor will provide outputs in the form of another data structure, and they can't just be plugged together, right? So you have to put in a little bit of glue logic, and these JavaScript actors give you a very convenient way to do this. So this just retrieves from a turn input a number, and then constructs a data structure that it sends to its velocity output, which is simply the data structure in the format that the Scarab robot expects. Okay? So it's the glue logic, right, that stitches these things together and manages the data type incompatibilities. Okay. So what I'm going to do next is create an accessor from scratch to show you how to create a non-trivial accessor. In particular, this one is going to be a chat client, and if I'm successful in doing it in the remaining 15 minutes, I may end up having to cut and paste some stuff rather than typing it all in, but you'll get the idea, right? If I'm successful in doing this, I'm going to be able to create a chat application that can be accessed from somewhere else on the net. I'm going to be able to connect that to commands to the Scarab robot so that you can control the robot from somewhere remotely on the network, but that control is going to be mediated by my chat application, which is going to apply some security constraints to ensure that only certain people can control the robot. Okay? That's going to be the goal of this exercise, and I'm going to be able to create a distributed swarm. Okay. So start with a blank model and drag in a JavaScript actor. This is how you prototype accessors to begin with. And for this server, a chat application is going to need network access. So I now have a choice. I can go back to my web page and say, my wiki page, right, and see, let's see what are the modules that are available. Okay? So I can see some networking modules. So there's an HTTP client. Well, that's not going to work. A chat server isn't an HTTP client. If anything, it would have to be an HTTP server. The TCP socket client might be a reasonable choice, but a socket can't be invoked from a web page for security reasons, but a WebSocket can, okay? So I could create a WebSocket server that will be able to accept commands from a browser. The browser will be able to instantiate a WebSocket client. The browser is not able to instantiate a WebSocket server, again, for security reasons, but it is able to instantiate a WebSocket client, okay? So if I go to WebSocket server, I have a module definition here, and it tells me, okay, there's a server class. When I instantiate the server class, I provide some interface information, okay, the host interface, the port, data type handling, and then I can put in listener functions, okay? So let me create this accessor that will be a chat client. I look inside this accessor, get rid of the comment, okay, and everything pretty much always starts up with exports.setup equals function, and inside this function I'm going to define an interface, okay? So what inputs and outputs do I want? Well, my inputs are primarily going to come in over the network in this case, so I probably don't need any actor inputs, but I probably should have some outputs so that I can, for example, log what's happening. So let me create a log output. So I'll say this.output, oops, and create an output named log. Sorry, what? Yeah, typo, thank you. Watch for typos, because as I said, doing this live, it's amazing how much you don't see your typos when you do this. Okay, so I applied this by just hitting Command S, and the log output port appeared on my graphical interface, all right? Now I could provide parameters for a host interface and a port, okay? And let me go ahead and do that. So I'll say this.parameter host interface, and I can provide some options such as a data type. Host interface should be a string, and a default value, say localhost, okay? This is a common pattern where in invoking this parameter function, I've specified the name of the parameter and then a set of options. Here, I could have specified options for the log output also, but I decided to just accept the default options. Okay, so I didn't specify any options. I could similarly specify a parameter for the port, which should have type int, and let's default to 8080. Okay, whoops, there must be a typo here. Oh yeah, this is an int, not a string. Okay, so now I apply it, and now if I go back here, I see that those parameters have now appeared in the parameter interface. If I double click on this guy, I've got a parameter for the host interface, a parameter for the port. Okay, so now let me give it some functionality. This is oddly indented. Here's the end of my setup function, okay? So let me create an exports.initialize function. And what my initialize function is going to want to do is start up a web server, okay? So I could say var server equals, well, what should it equal? Well, here's where I have to instantiate the module, right? So the module is needed. The module provides a server class that I can instantiate, okay? But I have to instantiate the module before I can instantiate the server class. The way to do that is just with the require function. So I can give it an arbitrary name, okay, for my module. Let's call it web server, and say I require the module named web socket server. I have to get the name exactly right, okay? And then my server is a new web server.server, which I can then, specify options to. Okay. Again, this is documented here. So the server class is instantiated using new. It says that here somewhere. Okay, using new. And you provide it with an options argument that can contain up to these 4 options: a host interface, a port, a receive type, and a send type, which are MIME types. So let me just provide the host interface and the port. Okay, so I'll provide a host interface, and the value of the host interface I want now to be the value of this parameter. Okay, so the way that I do that is with this dot get parameter host interface, and then the port similarly will be this dot get parameter port, and now I've got hopefully an instance of a server. So what can I do with this server? Well, again, I can go back to the documentation for the module to see what its API is. But rather than just bouncing back and forth, I'll just go ahead and do it here. So I can listen for events. So in particular, I can say, well, when a connection is established, invoke this function. The function will be passed as an argument, a socket, which is in the web socket that was just opened. Okay, so anytime that I open a socket, this function is going to get invoked. Okay, and I can do things like send a reply. Okay, and I can produce an output, right? So I should produce an output to my log output. So I could say this dot send to my log output a message, new connection. Now, there's a bug in this code. Any JavaScript experts who can spot it?
I'll guess this for $1.
Yeah. Yeah, you got your $1.
Okay.
This is a completely arbitrary thing when this callback is invoked. When the initialize function is invoked, it's the accessor. But when the callback is invoked, who knows what it is? All right? So I need to capture this. Okay, so that within the callback, I invoke send on the accessor. Okay? Okay, so finally I can do server.start. Once I've listened for connections, this will start the server. But now I have a problem, because if I run this, I'm going to start the server and never stop it. That's maybe not a good idea. So let me, instead of having this be a local variable with an initialize, I will make it an accessor variable outside of the initialize function. And I will define a wrap-up function that says, if in fact I have a server, stop it.
Edward,
Okay.
what's the scope of that server variable? Like if I have another accessor, can I access server?
No, this is the actor model. So it kind of looks like a global variable, but it's local to this actor. So this is a state variable of the actor, invisible to any other actor or accessor. The only way the actors interact is through messages, right? They have to send messages on their ports. They don't share data.
And is that true also like on the node host if I did something similar?
On the node host, you can actually sneakily get access under the table, okay? But you don't, you have to work at it, all right? You don't accidentally share global variables on the node host. So, but on the node host, everything is running within a single JavaScript interpreter, and there is a global scope, and everything is within that global scope, so you can actually get access to stuff you shouldn't be getting access to. On the CapeCode host, every actor actually runs its own JavaScript interpreter, so they actually have no mechanism for interacting with one another and sharing variables.
Okay, thank you.
Yeah. Okay. So now I have the very beginnings of a chat server. Let me see if it runs. Okay. If I'm lucky, it'll run. If I'm not, there's probably some error here somewhere because there almost always is. But what the heck? Throw caution to the wind. We try to run it. Seems to be running. Okay. So can I talk to it? Well, in theory, it's listening on port 8080 of localhost for a WebSocket connection. So there is, let's see, I have here a WebSocket client accessor instantiated in my browser. If I point it to localhost 8080 and say react to inputs, notice I got a response at the bottom of the screen, hello, okay. On top of that, the display displayed new connection, okay. So now I have actually already created a distributed swarmlet. Now I can instantiate another client to talk to it. So in fact, by the way, this WebSocket chat application is one of the demos. So the one that I'm writing from scratch is in the demo suite. There's a client in there as well. If this is set to, localhost 8080, so it's set to the right place. If I run this, I get an interactive screen where I can type something in, and I got the new connection again. Okay, I got the reply when I made the connection. So I've got the infrastructure, the basic infrastructure now for a distributed swarmlet. Okay, so we're just about out of time, so what I'm going to do is instead jump to a more complete implementation of this. Okay. Let me stop these and go to the demo. So WebSocket Chat has an elaborated server that does a few additional things. If you look inside the code, you'll see it's got the same pattern. It's the same interface that I just defined. It instantiates a server. It provides a callback function for a connection. Within that, it provides a callback function for a message. Notice this chain of callbacks, right? This is very common in this asynchronous atomic callback mechanism. You have a callback that registers another callback, right? And those can get quite deep, and that's one of the potential limitations of that AAC model of computation. But if you're using it in a contained way like this within an accessor, you end up with more shallow chains of these callbacks. Okay? So this particular variant of the server, if I run it, when I talk to the client, it asks, the first message it sends in response to a connection, notice new connection appeared. It says, what is my name? Well, tell it my name, Edward. It responds, hello, Edward. And then I can send whatever messages I like. And if there's any other client instantiated, they will also receive this message. Okay? So let me instantiate another client, which is a completely whimsical one. This is a WebSocket client that is connected to the same WebSocket, listening for commands. And then it has a simple little bit of glue logic that if it receives the message move, it issues a command to the robot. And if it receives the message stop, it issues a different command to the robot. Okay? So I run that, and it, notice it popped up another dialog, another display here. So this is connected to the socket, okay? So now, if I say move, exclamation point, the robot starts moving. Oh, rats, so you don't, I have to fire up a camera for you to see that, don't I?
Or if you, for those of you watching along at home, you can click on the black screen and make it full screen, and then you should see Edward. So you can't see the model running at the same time, but I can, you know, the robot is spinning.
The robot is spinning, take my word for it. If I instantiate another client, so let me go here and in a different process altogether. Let's see. Wait a minute. Let me just instantiate the client, another client, in another process. This could even be running on a different machine. Okay. Instantiate another client. It asks me what my name is. I'll say my name is Lee. It says, "Hello, Lee," and I'm not, oh, these are probably coming from the robot. I can say stop here. And notice it says, Lee says stop, but the robot didn't respond because that was Lee saying stop. If Edward says stop, the robot stops. Okay? So now this is an illustration of a distributed swarmlet where the chat server here is mediating access. It's mediating access to something that's, you know, potentially elsewhere on the network. If you build in authentication into this, it can give you a way to have these distributed swarmlets that will, you know, be able to regulate the control over things. Okay, so that takes us to 12:30. Every talk should include some PowerPoint. So just a few more things, and most of this we've already gone through, but we'll post this. One of the interesting things about the CapeCode swarmlet host is the way that it handles timing, which I will not get into. This is a snippet of a much more elaborate application. This is the one that was demoed with 4 of these Scarab robots at the DARPA Wait What demo. There's other timing issues. Here's one that I wanted to highlight, is that out there are quite a few lightweight embeddable JavaScript engines that have appeared. One that I particularly like from my limited look is one called Ductape, which comes from Samsung. I like it because it integrates very nicely with CapeCode, and it has a very small footprint, a really surprisingly small footprint, so it can run on pretty lightweight hosts. And I believe that we should be able to take programs that are defined in CapeCode, like this, as block diagrams, and create an export to Ductape that will produce a composite accessor that we can then instantiate in Ductape on an embedded processor. That's one of our goals moving forward, is to be able to create that. Okay, so I'll stop there, and I guess I didn't allow much time for questions, but I'm willing to hang around if there are questions or comments.
Thanks very much, Edward. If anyone has a question, can you chat with me or raise your hand or otherwise use the UI and I'll put you on voice. Does anybody in here, there's actually like, I don't know, almost 12, 15 people in 337. Does anybody here have a question? Has everybody been reading their email? Okay. No questions down here. And it looks like nobody's signaling me, so I think we can call it done.
Renee has a question. You want to ask your question?
Yes, 2 questions. The first, you mentioned that the node implementation right now is just interactive. for what I understood from your explanation, if we want to run host, that means something that can you put your accessor and then just run, the host shall be modified? Is that,
well,
did I get this right?
You could modify the host, or you can also use the interactive host as an engine. Let me show you how to do that. Okay. So
yeah. While Edward's bringing that up, Renee, we're using Mocha as part of the nightly build, and we're invoking Node, and we're just invoking the Node host, and it's a little, it shows a prompt, or it shows things like that, but it actually just works really well. So
here's an example of using the Node host. This is in the README file, okay, where I've provided a test script, okay, and if I just execute that on the command line, it runs the script and then exits. So you know that's a mechanism that you can use also to just use the Node host unchanged. But the Node host, the interactive Node host, I'm really convinced that that's not the most interesting use of the Node host. I think probably writing custom scripts is more interesting.
May I ask another one?
Sure.
In the test suite that you showed in the website, I saw that you have a regression test for particular accessors, but I didn't get or I didn't understand quietly. If I or the rest of the accessors cannot use this test suite. Am I correct?
No. The test accessors, the test library are accessors like any other, so they can be instantiated in any.
But it's not for everyone. It's just samples to do regression tests.
It's just samples for doing regression tests.
That's what
those are not meant for building swarmlets.
Okay.
Right. You shouldn't build swarmlets out of the test accessors because they're not. Most of them don't provide any interesting functionality. They're just testing capabilities of the host, right? And,
okay, so let's call this a wrap. We're a little bit over time. So thank you very much, everyone, for attending, and thank you very much, Edward. Okay, thanks. Bye-bye.